In this car, the instrument cluster is sent the speed signal via CAN. I wanted to find out, in other cars before implementing this type of tech, how are they sending the speed signal? I went to the Galant. Our speedometer is getting its signal from the engine computer, just like this one, but instead of getting it via CAN, it's getting it via a speed signal output on this line. And then the secondary speed sensor is inputting the speed signal from the gearbox into the engine computer, exactly how we have in this. Then I had this idea: is there a possibility that in this engine computer, is there a possibility that there is a system that uses this analog signal out? Right here at the bottom, we have a vehicle speed detection connector. The radio is going to automatically send a high-pitched signal to warn you that you are overspeeding. That signal is detected from the speed sent out here. Here it is, vehicle speed signal input. And look at this, the normal state, 0 to 5 volts pulse signal. And check that out, we have 12 volts on that line. That line is hot as hell. Quick cut of that wire, and we're still taking that signal. I want to see how the speed signal looks like. So let me put the battery back. Let's go to the scope. This is interesting. I wasn't expecting there to be a square wave here, but we do have a square wave. But look, we're not reaching a full ground. That 12 volts has slowly been cooking that circuit, and that ground has been elevating, so it has damaged the circuit. Okay, onto the bench. Let's repair this sucker.
We shall overcome. We shall overcome. We shall overcome someday.
So we're at the bench and we're going to repair this ECU. Now, if you're wondering, why am I repairing this ECU? Why don't I give it to somebody else to repair? Well, this is the reason. Now, I'll tell you something about this sticker right here. This sticker belongs to the most famous ECU repair company in the country. These are the guys who repair these ECUs, and they get 80% of the client base for people who need ECUs repairs. If this is the work that they can do, well, that should tell you about the sorry state of the industry in our country. I never wanted to get into ECU repairs or programming, but I've learned to do it simply because I cannot trust people to do it. My work is meticulous, and I do not do work like this. So let's start by opening this. First of all, why was this done? Obviously to get into this ECU, and I'll show you why. So I've already opened this one. This ECU is particularly difficult to open. You've got 4 screws, which are hex screws at the corners, and then you have got 1 screw, which is a Phillips in the middle over here. It's under some kind of molding. The problem is there is no pry surface on this ECU at all. So what I did was to create that pry surface. So I took a Dremel tool and I used this bit right here. It's one of my favorite bits. And I came and created a slot over here, just a thin one here and here. And then, and after creating that slot, now I have a prying surface that I can use with my screwdriver. And when I do that, it easily opens the ECU and they can break the glue bond. So that's what these guys did not think about. That's why they ended up doing that. The other issue is that's the backside of the ECU. Let's put that aside. Now this ECU has got a very nasty design. The connectors are part of the case. You cannot separate the connectors from the case. This is one molding piece. So what I had to do was to come here and desolder all these pins, and then the ECU board could now come out. Is it impossible to do? No. Does it take more time? Yes. But this is not impossible. Why not just do it and bill your client for the time it takes to do this? So that is our board. And then I made sure that I clean this board nicely. Alcohol exclusively does not work for me when cleaning PCBs. What it does is to smear the flux all over the place, and you get fine traces that remain. So what I've realized is if I use alcohol to do the coarse cleaning, and then I use home dry cleaner, which is just naphtha, liquid naphtha, to do the fine cleaning, and that's how I get a very clean surface like this. So that's our ECU. Now we need to figure out what is wrong with this unit. I have already mapped the pin in question. Our pin is this one right here. So we're going to follow this pin and we're going to trace it out, and we need to find the driver that produces the square waves for that pin. This is our output pin, the one that takes the square wave out of the computer. So if you follow it here, it comes to this component. This component is a jumper. If you can see this one, this is also a jumper, J14. So this is a jumper. This side, this is a diode, D92, but our microprocessor is that side. So we're going to go towards our microprocessor. So let's follow this line here. It goes around, comes to this leg of the diode. Now this diode brings in our 5 volts from here, comes through a dropping resistor, and then this is the one that's connected to our signal line. Now if you notice, that track is thick, that track is thin. That tells you this one is the one that is a signal line. So whenever we pulse the 5 volts, we only pulse this side of the resistor. We don't affect the main 5 volts that comes from this other side. And this side here goes to our microprocessor for the gearbox, which is this one right here. Okay, so let's keep going. This is our conditioned signal line. It comes around, comes here, goes across, comes down, and it terminates over here. Now where does it go from here? From here, it comes to this pin. Okay, so it just goes through the underside of the board and comes out there. And what do we see here? This component is Q107. Q is transistor. So this is our transistor. So I'm going to do some checks on this transistor. So the first thing I want to do is to measure which is the ground. Now transistors of this type are always standardized. This is the base, this is the drain, and this is the source. The source should be connected to ground. So if I put my meter to ground, and then I come here and let's touch the source, you can see that's connected to ground. This is our base. It's supposed to be connected to our microprocessor, and our microprocessor is on this side, and it comes to one of these pins, the microprocessor. As you can see, it comes on this line and it ends up on the microprocessor. So now we know our base. Now let's test this transistor. We're not supposed to have any continuity between any of these three lines. So let's test between our source and our base. That is good. And let's test between now our source and our drain. That's also good. Now let's test between our drain and our base. And look at this, we have a short on that line. Now this is interesting. That means that that square wave that we saw was not a partially alive driver. This driver is dead. My goodness, we were actually seeing the microprocessor activity. So when we have 5 volts, we see the line that has 5 volts right here. But when you see 2 volts, we are now connecting the base and the drain, and we are actually seeing the 2 volt signal coming from the microprocessor. That is interesting. So because of this resistor right here, we have protected the microprocessor line from being shorted. So that's our problem. Let's take out this transistor and then ensure that we no longer have a short in our line. All right, we have removed that component. Now let's test between the base and the drain, and now we have no short. I'm going to test between source and base, no short. Okay, so what component is that? Well, this tells you here Q is a transistor. But is it a regular transistor or is it a MOSFET? You have to understand, what is this circuit driving? Is it driving a load or is it driving a signal? If it's driving a load, you put a MOSFET. If it's driving a signal, you put a transistor. So we are going to put a transistor here. Let's go to tme.eu and we're going to look for an appropriate transistor to repair this board. All right, here we are at tme.eu. Now, outside the US, this is the best resource that I have found for semiconductor purchases. Of course, in US, you have DigiKey and Mauser. There is another place, and that is the UT Source. These ones, I think, are based in Taiwan, but they have outlets also in China. I prefer these guys for older IC chips, for older ECUs that are harder to find. They usually have them because they also specialize in stripping off boards that are working and selling secondhand stuff. So that is UT Source, but we're going to use TME. So let's come here and search for transistor. And we're going to look for semiconductors. And we're going to do bipolar. And it's NPN. Now the reason why it's an NPN is because we have a positive turn on from the microprocessor. If we had a negative turn on, then we do a PNP. But microprocessors, I've never seen them do negative turn ons. They usually do positive turn ons. But you put PNPs other places in the circuit where you turn them on via a ground. So let's go to NPN transistors, and it's SMD, which is surface mount. And right here we've got several filters. The first thing I want to filter is for the automotive industry. Now, if you buy other transistors, they will work, but automotive transistors are specially designed to withstand heat and vibration, and that is the conditions in cars. So here we have NPN already, and Nexperia is a good company for automotive transistors. So of course we need SMD. Yeah, let's filter that for now, and then we're going to only filter the ones that are in stock, and these are the ones we have. So I'm just going to pick any of these. I'll just pick the first one here, BC846QR. Let's go in there and let's look at the data sheet for this one. Here's the documentation. Now it's an SOT23 package. Oh, I should have filtered for SOT23 only. This is the type of package that has got the 3 legs, the same type that we removed from our device. But I want to see the nominal turn-ons. This is what I meant by SOT, by the way. This is the package it comes at, and it's usually standardized. So we've got pin 1, 2, and 3, and it's pin 1 for the base, pin 2 for the emitter, and pin 3 for the collector. If you forget what these are, just know you're collecting a signal here and you will emit it out of this. In our case, we are collecting a 5-volt signal and emitting it to ground, and we turn it on via the base. So let's look at the operational value. So these are limiting values. We've already seen that at 65 volts, that's when you blow open the transistor. But I want the operational voltages. Remember, our turn-on voltage from the microprocessor is 2.5 volts. So let's see here. The base saturation voltage, so we saturate it at 760 millivolts. That means the threshold is 760, which is good, 0.76 volts. And remember, we are turning on from 0 to 2.5 volts. So this is well within our turn on range. So this will work for our needs. So we're going to come here and we are going to order, let me order 10 pieces for now. There we go, added it to cart, and let's check out, and then we are going to wait about 2 weeks for this to arrive, and then we're going to continue with our project. And we have our package. That's why I like TME. They are very quick in shipping. Often ship the same day you order if the item is in stock. Let's open it. So I bought 2 items. This is our transistor, NPN bipolar, and this is an N-channel MOSFET because I need these a lot. People who blow up computer drivers for the main relay by installing those silly alarms. This is what goes out. We don't need that one, we need the transistor. I just bought a pack of 10, and that's how they come. So we're going to cut one out and then put it on our board. So let's bring the board out and repair it. Alright, there's our final result, and now we're going to test whether we have continuity in the right places. So the first place to test is this. It's supposed to go to ground, and that's a good ground, and we need to make sure that the chip itself has continuity to ground, which it has. Then we're going to test the base and the drain, and this is good. Now we do not have continuity there. Okay, and just to make sure that we have got a good contact, let us test there. That's good. And then for this one, we are going to test it here. All right, so this is excellent. Okay, that is done. Now we're going to put this board back, and we're going to go back to the car and test it. All right, I have put the computer in. I've not put the bracket. I just want to see whether this speedo will work. So let's go to the car and drive this thing, see if the speedo works. All right, here we go. Moment of truth. Let's put the key on. Start. And we're just going to drive down this lane, see what happens. Here we go. Oh, baby! Yes! Ha! Oh! We are working! The speedo's working! Oh, that feels so good! Oh, that's amazing! After 4 months, now the speedo is working. Oh, guys, this feels so good. Okay, so now what I want to do now is put my Pico on this, and then we're going to get the capture of that speed line. And I know what I'm going to see, of course. It's going all the way down to 0. But this is fantastic. I won. Okay, our Pico is ready, and we're going to take a capture of that square wave. First, let's put the key on. And there we see we've got 5 volts on the screen. So let's start. The other time we had about 2 volts. And now we're going to drive down this road and see what we get on the scope. All right, here we go. And look at that. That's a beautiful square wave we have on the screen. And just another shot again. Our speedo is working. Very nice. So let's just come here, and I'm going to pause. Let's look at that capture. So we can see that now we are moving from a clean 5 volts all the way down to 0. So our square wave is complete, and that is why we have speedo. What a journey. This has taken 4 months. Now I'm sure some of you will wonder, how come it has taken 4 months? Well, look at my part 1 video. First of all, this was not a paid job. I'm doing this job as a favor for a friend of mine who gives me very good jobs from a garage. But I did tell him that it depends on my work. I came, I diagnosed it the first time. I did not have any service information, and I couldn't get anywhere. I had to wait for my service information to reach from Japan. Then I came back, diagnosed a bad engine computer. Then we had to wait for about 3 to 4 weeks for a computer to come. We put the computer in, and the computer malfunctioned because of the line coming from the radio. Then I had to go and think about what's happening. Came back, diagnosed that we have a bad line, a hot line coming from the radio to the computer that was blowing the driver. Then I had to, in the midst of my work, remember I'm still working when all this is happening. In the midst of my work, I came, I took the engine computer, took it home, opened it up, and had to look for which driver is bad. Then I found the bad driver. Then I had to order it because we don't have those in the country. Ordered it from Europe. That took about 3 weeks to come. And then it came. And then I was still busy, but finally got to sit down. And then we did the repair. And now it is fixed. This is really good. And if this was a paid job, of course, I might have tried to do it faster, but still it would have been slow because we had to import stuff from Europe. But we have succeeded. Remember, service information is key. You have to have the right service information. Do not panic when things don't work out. the way you need them to work out. Slow down, gather your thoughts, go back and see what you have missed. In this case, we found that we had missed another speed line coming from the computer. Thank you very much for watching, and we'll see you next time for another good diagnosis.
The strong